Have you ever thought how the traffic light timing works without human intervention? Have you ever thought how the microwave oven flips off as soon as its time is up, or based on 30 seconds is up, based on the timing that it is set by the user? Because microwave oven, along with monitoring the timing, it will also be preheating the food that is being kept inside. Yes, it will be doing multitasking. How is it possible? It is possible for these systems to perform the multitasking just because of the dedicated hardware present inside. Yes, there will be the dedicated hardware to monitor and control the timing which are present inside these systems. What are these dedicated hardwares? These dedicated hardwares are nothing but timers and counters. Yes, these dedicated hardwares are nothing but the timers bar counters of 8051 microcontroller. Namaste, myself Dr. Sharda Gupta, working as an Associate Professor, Department of ECE, SSIT, Sahe. In this video lecture, I will be giving more insights on the timer and the counter registers present in the 8051 microcontroller. These timer bar counter registers are the registers which are present inside the 8051 microcontroller. These are said to be the dedicated assistants to monitor and control the timing purpose. By making this, CPU will be left free to perform its own task. With that, CPU can be performing its own task. The timing control action will be taken care by the timer and the counter registers. Basically, there are two timer registers which are 16-bit register. The same registers will be used as a counter. As shown in the slide here, there are two basic timers, timer 0 and timer 1. Both these timers are of 16-bit register. In the timer 0 of 16-bit register, the lower 8 bits are dedicated for timer 0, which is said to be timer 0 lower byte. The higher 8 bits are said to be the timer 0 higher byte. Similarly, in timer 1, the lower 8 bits are said to be timer 1 lower byte. In timer 1, the higher 8 bits are said to be timer 1 higher byte. These two registers can also be used as a counters and also as a timers. When 8051 is said to be, it is counting. What exactly happens, what exactly it means, exactly what happens is the bit values in the timer will be keep changing. That is, the bit values in the timer register will be keep incrementing. By default, the value present in these registers will be 0000H, H indicating the hexadecimal value. Whenever the clock ticks, the value will be incremented by 1. It will become 000H to 0001H. Whenever the clock ticks again, the value will be again incremented and the value is 0002H. Similarly, as keeps on the clock ticking, the value will be keep incrementing and the final value or the maximum value it will reach FFFFH. Why? Because all the bits in the timer register will reach its value, that is 1, and that maximum value is said to be FFFFH. Whenever it reaches its maximum value, it is said to be that the timer has reached its maximum limit and some amount of delay is being generated. We have told it is the timers, it is the counter. Now the confusion is, are these timers or the counters? Yes, technically speaking, the same hardware works as timers and counters. Then how to differentiate? Yes, to differentiate this timers or counters, we will be working on the application. These timers and counters will be differentiated based on the application. If these registers are used for generating the delay, we will be considering it as a timer. If these registers are used for counting application, these registers are said to be the counters. Say for example, if the timer register is used to blink an LED after certain time period, or if an timer register is used to give a signal in a microwave oven after certain time period, this means it is used to generate the delay. It is said to be the timer. If it is used for the application of counting the number of items on the conveyor belt, it is used for counting the number of people passing through the entrance. This is for counting application. In that case, these registers are said to be counters. Summarizing, timers are basically used to measure the time. Counters are basically used to count the events. Specifically speaking, If the registers are used as a timer, the click comes from the internal clock. If the counter is used as a counter, click comes from the outside world. What is this click? This is nothing but the tick which occurs from the oscillation. This will be generated from the internal oscillator present in the 8051 microcontroller. Like how fast the value present in these register will be kept incrementing by 1. That is called as frequency of these timers or counters. Basically, these frequency of timers or counters dependent on the internal clock frequency of 8051 microcontroller. As we know, there is an internal oscillator which provides the clock frequency in 8051 microcontroller. If the oscillator frequency of 8051 microcontroller is x megahertz, the timer clock frequency will be x megahertz by 12. It means 1 by 12th of the oscillator frequency will be the timer frequency. Similarly, if the oscillator frequency is 12 megahertz, then the timer frequency will be 1 by 12th of that, which is nothing but 1 megahertz. Similarly, if the oscillator frequency is 11.085 megahertz, its timer frequency will be 1 by 12th of that value, that is nothing but 0.9216 megahertz or 921.6 kilohertz. So we know that the timer frequency basically dependent on the oscillator frequency of the microcontroller. Standard frequency of 8051 microcontroller is 11.0592 megahertz. It can be varied also. Based on the variation of the oscillator frequency, timer frequency also will be varied. That is 1 by 12th of the oscillator frequency will be the timer frequency. Whenever we have to work these two 16-bit register, which is nothing but either timer 0 or timer 1, either as a timer or a counter, we need the help of two special function registers. In the short form, we call it as an SFGs. What are these special function registers? These two special function registers are TMOD and TCON. TMOD stands for timer mode register, TCON stands for timer control register. So both of these registers are of the size 8-bit as specified in the slide. So the internal address of this TMOD register is 89H, the internal address of TCON register is 88H. What is this internal address? If I have to access these two registers, I can access these registers either by the name called TMOD or by the address called 89. Similarly, if I want to access the TCON register, I can access it by the name TCON or I can access it by the name address 88H. So the one which has been shown in the figure in the slides are the bits values of the TMOD register and the TCON register. There are basically 8 bits present in the TMOD register. The upper 4 bits is dedicated for timer 0 and the lower 4 bits is dedicated for timer 1. As we can clearly see here in the slide of the bits of TMOD register, the lower 4 bits is very much similar to the upper 4 bits. But the action is also the same, but the action of the lower 4 bits is for timer 0, the action of higher 4 bits is for timer 1. Similarly, there is another special function register called TCON, which is also an 8-bit register, in which it is consisting of an 8-bit. As we could clearly observe here, there are 8 bits, upper 4 bits are dedicated for timers and the lower 4 bits are dedicated for interrupts. In this video lecture, as we are concentrating only on the timers, I will be not concentrating on the lower 4 bits, I will be concentrating only on the upper 4 bits which are dedicated for the timer applications. As we could clearly understand till now, whenever we want to work with the timers and the counters, we need 4 registers. One is timer 1 and timer 0 by default, which are of 16-bit register. In order to work with this, definitely we need the help of 2 more special function registers called TMOD and TCON. Why? It's almost similar like your fan. As we know, there will be a fan in a room will be turning on and will provide a good air for us. But the one which is working is the fan, but switching on and switching off control will be in its switch. Similarly, in what speed it has to work will be controlled by the regulator. In the similar way, the one which will be providing the delay or one which will be giving us the counting pulses is the timer register. But the switching on and switching off of these two timers will be done by the help of these bits present in the TCON register. Say for example, if I make this particular bit 1 or 0, based on that the timer value will be set or it will be reset. Similarly, in what frequency this particular should work, whether it is working as a timer or it is working as a counter, these things will be decided by the bits present in the TMOD register. As indicated earlier, the lower 4 bits are dedicated for timer 0, the higher 4 bits are dedicated for timer 1. Whether it should work as a timer or counter, in what way it will be working, that will be decided. In what mode it will be working, that will be decided by the bits present in the TMOD register. So, for a fan, it's like these timer registers are a fan. Switch to turn on and turn off is nothing but the T-con register. In what mode, what speed it has to work is nothing but the TMOD register. So, in order to program the 8051 microcontroller timers or counters, we need the help of all these 4 registers. Now, in the further slides, we shall try to discuss more about this TMOD register. As indicated earlier, TMOD stands for timer mode register. As the name itself indicates, in what mode of operation that the timer 0 or timer 1 should work will be decided by the values that will be keeping on these bits of timer mode register, which is called TMOD. The lower 4 bits is for timer 0, higher 4 bits is for timer 1. As we see in the lower 4 bits, there are 2 bits called M1 and M0, which are called as mode selection bits. As these are the bit values, the value can be present in these bits will be either 0 or it will be 1. If both the bits are 0, 0, the timers are said to be working in mode 0. If both the bits values are 0 and 1, the timer is said to be in mode 1. Similarly, mode value is 1 and 0, it is said to be mode 2, 1, 1, it is said to be mode 3. What is this different modes? This mode 0 is also called as 13-bit timer mode. As we know, there are 16 bits in the timer register, either in the timer 0 or in the timer 1. Whenever it is working in mode 0, only 13 bits out of those 16 bits will be working. Similarly, whenever it is working in mode 1, which is also called as 16-bit timer mode, all the 16 bits of both the timer 0 and timer 1 will be working. Similarly, whenever it is set to be in mode 2, which is called as 8-bit, in this mode only 8 bits will be working, that will be TL0. A copy whatever we will be loaded into TL0 will be also there in TH0. As a copy by default will be copied to TH0, the mode is also called as auto reload mode. Other one is mode 3, which is called as split timer mode. Here the timer registers are split into 2 different timers like timer 0 lower and timer 0 higher. Let us see in further slides the detailed operation of these particular slides. This is all about M1 and M0 bits present in the TMOD register. The other bit is C by T bar. As we can clearly observe here, this value will be either 0 or it will be 1. Whenever it is 0, it acts as a timer. Whenever it is 1, it acts as a counter. So, as we can clearly see here, a variable, standard variable indicates the value 1. A variable with a complemented variable will indicates the value 0. So, whenever this bit is 0, it acts as a timer. Whenever this bit is 1, it acts as a counter. The other bit is gate. As we can simpler way we can tell, like whenever the gate bit is 0, starting and stopping of the counter will be in the form of a software. Like through the instructions, through the programming itself, we can start and stop the timers or counters. Whenever the gate bit is 1, the starting and stopping of the timer will be under the control of hardware. That means we may have to connect some extra unit in order to turn on and turn off the timers whenever the gate bit is 1. So, these are the significance of all the 4 bits. The same 4 bits whatever there is for timer 0, in the similar way these 4 bits will be working for timer 1. Another special function register that we have mentioned earlier is a T-con register, which is called as timer control register. As I told, for a fan it acts like a switch. Whenever you press it, timer register will on. Whenever you press it again, the timer register should off. Which bit has to be pressed? Similarly, as I mentioned before, the upper 4 bits are the one which are dedicated for the timers. TR0 stands for timer 0 run control bit, timer 0 overflow bit, timer 1 run control bit and timer 1 overflow bit. These 2 bits are dedicated for timer 0. These 2 bits are dedicated for timer 1. By default, all the bit values will be 0 itself. Whenever I make through the instruction or through the program this value as 1, the timer 0 register will be starts working. What does it mean it starts working? By default, the value present in the timer 0 will be 0000H. Whenever I make this particular bit 1, the value will be keep incrementing every time. Every time means for every time period. If the standard frequency is 11.0592 megahertz, the time period will be timer period will be 1.085 microseconds. So after every 1.085 microseconds, the value in the timer registers will be keep incrementing whenever I make this value 1. So as soon as the value keeps incrementing, as soon as it reaches its maximum value called FFFFH, right? At that particular time, this bit will automatically becomes 1, indicating the programmer that the maximum value in the timer has reached and some amount of delay is being generated. Similarly, these two bits works for timer 1. Whenever these bit, by default, the value present in this bit will be 0. As a programmer, if we write the instruction to make this particular bit 1 and if we make this particular bit 1, automatically timer 1 starts working. Starts working means what? The value present in the timer 1 register will be keep incrementing by 1 every time. As soon as it reaches its maximum value, the TF1 will become 1, indicating the programmer that the maximum value has reached and certain amount of delay will be generated. Again the question is, what is the maximum value? As I told now, the maximum value is FFFFH. It doesn't mean the maximum value always will be FFFF, because it works in different modes. In which mode it is working, based on that the maximum value will be finalized. Say for example, if the timers are working in mode 1, all the 16 bits will be working. Obviously, the maximum value will be FFFFH. When the microcontroller timers are working in mode 0, it is said to be 13 bit. Out of 16 bits, only 13 bits will be working. So the maximum value here will be 1FFFH. As I mentioned before, H indicates the hexadecimal value. Whenever the timer registers are working in mode 2, it is only 8 bit, so maximum value is FF. Similarly, mode 3, it is a split bit timer mode, it is also an 8 bit, the maximum value will be FF. So this is all about the timer register. As we have studied till now, there are 4 important registers necessary, that is timer 0, timer 1, this is one exactly which will be working the 16 bits, and in order to work with this we need the help of 2 special function registers, that is called as tmod and tcon. So whenever we write the instructions suitably to alter the bits present in the tmod and tcon, based on that only the value will be keep incrementing and certain amount of delay will be generated. As mentioned, either in 4 of the modes we can work depending on the application. So now we shall discuss the 4 important modes with respect to its operation and the block diagram. As mentioned, these timer registers can basically work in 4 different modes, that is mode 0, mode 1, mode 2 and mode 3. And in which mode it has to work will be decided by M1 and M0 bits present in the tmod register. So this can be altered either as 0 or 1 through the suitable instructions. So now we shall go through the timer mode 0 operation. Timer bar counter, as specified before, the same register will be working either as a timer or as a counter. Whenever the mode bits are 0, 0, it will be working in the mode 0 operation, and this block diagram represents the mode 0 operation. Let us see what and all is there here and what it specifies as. As we can indicate, as it is indicated here and studied before, the oscillator frequency has to be divided by 12, and 1/12th of the oscillator frequency will be the frequency given to us for the timer or counter. So frequency will be given by the oscillator frequency, and hence whenever T by T bar is 0, the frequency will be connected to this. What if C by T bar is 1? If C by T bar is 1, it means it is working as a counter. At that time, internal oscillator frequency will never be the clock source. Rather, we have to connect an external clock source through a suitable pin to make this counter work. So, whenever this C by T bar is 1, it means that it is working as a counter and the internal oscillator will never be the clock source. Rather, we have to connect an external clock source through the pin T0. This block indicates that whatever the frequency that we are applying, if it is for timer 0 or if it is for timer 1. Similarly, we have also understood that gate bit should be 0 whenever we are using the clock source. Stopping and starting will be done through the programming, through the instructions. It will be 1 whenever starting and stopping will be done by the external hardware. So, we have to also make sure that the gate pin should be 0 along with the proper external connection which is given through the INT 0 pin. With that, we have to provide the suitable value in the control bit. Hope everybody remember in the previous one, as we have mentioned, this TR0 is the timer 0 run control bit. If we make this 0, it will be, timers will be off. If we make this one, timer will be on. So, timer, in order to turn on the timer, we have to make this particular value 1. So, that is what it is indicated in this block diagram. That is, TR0 bit has to be 1 and these values to be given proper. If both are correct, then only the value will be given and the control will be started. So, the oscillator frequency should be given proper if it is for timer. External frequency should be given. If it is for counter, we have to give the proper selection in the TR0 bit. If this is done, it will be working in mode 0. Whenever it is working in mode 0, as we know, it is a 13-bit timer mode. So, out of all these 16 bits, only 13 bits will be working. That is, all the 8 bits in TH0 and only few bits in 5 bits in TL0. So, totally 13 bits will be working and TH0 mein all the 8 bits, TL0 mein only 5 bits. So, together 13 bits will be working and whenever we start the timer, the value will be keep incrementing and the maximum value here in this mode will be 1FFFH. So, as soon as it reaches its maximum value, that will be indicated by this interrupt flag which is there in the T-con register. So, whenever this bit becomes 1, automatically it is an indication to the programmer that the maximum value has reached and one set of delay is generated. Now, we shall see timer mode 1 operation. These parts remain same, like either it is working as a timer or a counter. Depending on the working of timer or a counter, we may have to provide the oscillator. If it is working as a timer, the oscillator frequency should be given divided by 12 and that 1 by 12th of the frequency will be given to the timer. If it is working as a counter, we have to provide the frequency through the external pin. Similarly, we have to provide a gate pin, a suitable value in the INTO pin together with either we have to go with TR1 or TR0 depending on the timer. TR1 is for timer 1, TR0 is for timer 0. So, this is the particular bit which is present in T-con register. So, based on these values, the timer will get triggered or it will get started. What does it mean, the value, the timer will get triggered or started? The value present in the timer register will be keep incrementing. As we are working in mode 1, it is a 16-bit register, like all the 16 bits will be working. So, what will be the maximum value? The maximum value will be FFFFH. So, as soon as the clock keeps ticking, the value present in the timer register will be keep incrementing. As soon as it reaches its maximum value called FFFFH, it will be indicated by the interrupt flag called TF1 or TF0. That means TF1 for timer 1, TF0 for timer 0. So, as soon as this flag becomes 1, it is understood for a programmer that the maximum value has reached and he or she should stop the timer and some amount of delay is being generated. So, this is how timer or counter will work in mode 1. The next one is mode 2. Yes. So this block diagram represents the timer or counter operation in mode 2, which is called as auto reload mode. So what exactly happens in an auto reload mode? Let's see. The same oscillator frequency will be given, will be get divided by 12. Proper signal should be, if it is for the timer, proper signal should be given for T1 pin. If it is for the counter, then suitable value, that is 1, should be given in the TR1 register with this setup, has to be given to trigger the. So the value, once when the timer mode 2 gets triggered, the value will be keep incrementing. So in this only 8 bits will be working. Which 8 bits will be working? The value will be working will be TL, the lower byte of the timer register. Either it could be timer 1 or it could be timer 0, only the lower byte will be working. So whatever the value we will be loading initially, like that value will be loaded as a copy into TH also. But the one which is working whenever the timer is triggered is actually the TLX. So let's consider by default the value loaded into the TLX register is 000 itself, 00 itself. So the same 00 is being copied to TH1 also. So whenever this timer is getting triggered, at that time the value present in the TL1 register starts incrementing from 00. So now it will become 00, 01, 02, 03 until it reaches its maximum value. As its maximum value is 8 bits, that is FF, once after it reaches its maximum value, it has to rolls back to 00. If some predefined value is being loaded, the copy of that will be there in the TH register. So that copy will be automatically loaded back to TLX register. So hence this particular mode is called auto reload mode, which means by default as a programmer, if we are loading any value, we will be loading into TLX. A copy of that will also be stored in THX register. Once after the TL register counts and it rolls back to 000, the original copy will be loaded back to TLX register. So hence this particular mode of operation is called as auto reload mode. Once the maximum value is reached, it will be indicated by the timer overflow flag. If it is timer 0, it will be TF0. If it is timer 1, it will be TF1. So this is how the timer or counter register will be working in mode 2. Next coming mode 3. So basically timer or counter can work in mode 3, which is also called as split timer mode. So what is the split timer mode? In the split timer mode, there will be no working of timer 1, only will be working with timer 0. So timer 0 will be working lower byte, timer 0 will be working higher byte. So now how both these registers can work? So whichever the bits which were dedicated for timer 0 is now working for TL0. Whichever the bits which were dedicated for timer 1 will be now working for TH1. In most of the operation, in general generating the delay, we will be not using these timers in mode 3, rather we will be using this for the baud rate generation, which we will be studying in detail in the serial communication part. So till now whatever we have understood is, if the timer or counter is working in mode 3, it will be in two different, it is called a split timer mode. So the same timer 0 is separately works as TL0, same timer 0 will separately works as TH0. The timer bits of 0 will be now working for TL0, the timer bits of 1 will be working for TH0. So this is how mode 3 operates for timers and counters. So to wrap up, till now whatever we have studied is regarding the basics of timers and counters. As indicated in many of the slides before, in order to program with the timers and counters, it is very much essential to know the 4 basic registers, that is timer 0, timer 1, Tmod and Tcon, and the 4 different modes of operation, that is mode 0, mode 1, mode 2 and mode 3. In coming further lectures, we shall also learn how to write the program to work with these timers. Thank you.